I just finished building the fourth panel of my Serge Paperface system, and I thought I would do a quick video to show you what the modules are and basically how it works. Now, I won't get into the function of each module. I'll do that separately in other videos, but this will give you an overview of which modules are in there, as well as a few sound examples to hear what it is capable of. I've built this system over the last 2 years or so. The first two panels are the ones that I started with, and this is a 73 to 75 home-built kit, which has got a lot of the basic, most fundamental Serge Paperface modules in there. It's a good place to start. But then I got into Prism Circuits. I've built two panels from Prism Circuits now, and one of the many wonderful things about these is you can choose absolutely which modules you want and put them in whatever order you want. The PCBs themselves are separated module by module, which makes it much easier to be able to debug if you have a problem. The 73 to 75 PCBs are all one large plane of PCB, so in order to take something out to debug it, you would have to take the entire front panel off. Before I show you what each panel does, let's take a look at the power. Power is not a very sexy aspect of synthesizer building, but it is in fact one of the most important aspects of things. If you don't have good power and a reliable way to be able to distribute it to your modules, then you're sunk before you even start. This is the rear of that same synthesizer tower. And there are two power supplies in here, one for the 73 to 75 units and one for the Prism Circuits units as well as other boats that I am building. I have the power supplies themselves inside of their own boat, screwed in so that they can be as safe as possible. A couple of things. The 73 to 75 power supply here is just used to power those two boats. I have the power coming out to a pair of 4-pin XLR jacks that then go and power the systems themselves. For the Prism Circuit system, in which I knew that I was going to want to power more than just a couple of boats, I got this really high-quality Deptford power supply. It's initially set to be able to power up to 4 boats. For this system, I found these nifty airplane jack connections that have screw-ons. And so I've adopted that for these boats and for the rest of the boats that I build. They're pretty foolproof, the screw-on aspect keeps the things from going anywhere, and it works really well. One of the most important things about power when you're talking about a modular banana jack system is grounding. So over here, if you can see inside, there are grounding wires going from both power modules to a banana jack there on the outside. This jack here is then grounded to the rest of the banana jack synthesizers that I have in my collection. This is very important because while banana jacks are great for patching, they don't carry the ground signal, and so you need to make sure that all of your systems are grounded together in order to not get any ground hum. This is the first panel of the 73 to 75 home-built system. It consists of 2 positive Slew modules and 2 negative Slew modules. These modules are some of the real essence of the Serge philosophy. These modules can be patched any number of ways to be able to create oscillators, filters, lag devices, envelope generators. They're absolutely incredible. And if you use a positive and negative Slew together, you can create a full envelope. These are really the basis of the famous Serge universal slope generator, which came later. It then includes 3 envelope generators. At first, I didn't understand why they had 3 envelope generators on here. And in fact, if I was designing it, I would probably have 2 envelope generators and use this for some other kind of module. But that's okay. Again, because of the patch programmability of the Serge, these things are really useful. They don't just generate envelopes. You can also use them as LFOs and as pulse generators and other things like that. So they're really quite useful. Finally, at the end of this is an adapter that allows you to be able to go back and forth between 3.5mm and banana jacks. Now up here, I wired it in the back to have a pair of 1/4-inch jack outputs, and that's actually how I interface this Serge with the rest of the world. On top here, you may notice these little LEDs. This is a failed experiment in which I tried to be able to create some LED indicators to allow you to see what some of these modules were doing. But it was just too difficult in the long run to hold these in place and keep them wired up to these actual modules. This is the second panel of the 73 to 75 home-built kit. It starts with an oscillator. The oscillator is quite useful. It has a sine output as well as a variable wave shape output. It doesn't work with 1 volt per octave. This is a little too old-fashioned for that. But you can make tonal sounds as well as lots of atonal sounds with it. It's really nice. Next up is the triple wave shaper. This is a really famous Serge module that allows you to be able to distort and change the waveform of all sorts of different shapes that are coming into it, both control voltages and audio signals. After that, we have the peak and trough, which are a pair of very simple logic circuits. When you have multiple signals going into the peak area, whichever one is highest at that moment will be output here. And with the trough, any signal which is the lowest at the moment will be output right there. Next, we have the triple comparator. There are 3 of these in this module, and they each allow you to input 2 signals. It will then output a pulse based on which signal is higher at the moment. This is very useful for, among other things, creating a pulse wave based on a sine wave or a sawtooth wave or some other signal coming in. That's followed by the dual processor, which is a control voltage mixer that allows you to be able to create new and interesting, more complex control voltage signals out by mixing up to 3 CV signals. These are attenuverters, so each signal can either subtract from or add to the ultimate output. Next up is a gate, which is Serge speak for a VCA. We can never have enough of them, and this one works pretty well. Next up, we have a ring modulator, and what I really like about this circuit is that you can use it for both audio signals and control voltage signals, which I think is really interesting. That's followed by a spring reverb, which is attached to the back, and then finally a preamp, which allows you to input signals from the outside world through this 1/4" jack and then be able to use them within the Serge system. Now we move over to panel 3, and this is the first of the 2 Prism Circuits panels that I've built thus far. I worked with Sky King of Prism Circuits to be able to determine which of these PCBs would be the most interesting for me to start with. I really wanted to start with a number of CV generators with circuits that I didn't already have. And so the first thing that I built was a 5-channel programmer, which is Serge speak for a sequencer. It has 5 stages, each of which has 3 different CV signals that are output from these banana jacks here. You step it forward and backward by applying pulses here, and then pulse outputs are generated across each stage and right there. Next up is the bidirectional router. The bidirectional router allows you to be able to send 2 outputs to 1 input or 2 inputs to 1 output. The way that it works is that you put 2 signals here into A1 and A2, then you have a signal here in B, then you send a control voltage into this input right here, and that determines which of these 2 signals are routed to that signal. There are 3 of them. Then there's the sequential switch that allows you to be able to route 1 input to up to 4 different outputs. You can determine how many of the outputs, 2, 3, or 4, by that switch right there. And the way that it works is that every time you send a pulse into this clock signal, this moves down and causes the input signal to be routed to whichever output the LED is currently on. That's followed by the noise source, which generates a ton of random signals. We have white noise, we have pink noise, we have sample and hold and a source signal for sample and hold, and then we have stepped and random outputs right here. These outputs are triggered by either hitting the manual button or sending a pulse into this trigger input. That's followed by the wonderful Serge 73 voltage controlled filter. This thing sounds absolutely great. Input goes right there. You have an input volume knob, and then you have low pass, band pass, and high pass outputs all simultaneously. This is the filter cutoff down here. This is the resonance or Q signal, and this is a voltage-controlled attenuverter to allow you to be able to add to or subtract from the cutoff frequency of the filter. This thing just sounds wonderful. And then there is another gate here, because once again, you can't have enough VCAs. And that brings us to panel number 4, the panel that I finished, well, mostly finished yesterday. This panel has a couple of really key Serge modules, and I absolutely love it. The first 2 are a pair of smooth and stepped function generators. These things are absolute powerhouses of patch programmability, and I can hardly wait to do a video in which I delve into so many of the different things that these can do. They're just a ton of fun to be able to play with. Then there are a pair of these Serge Vactrol-based phaser circuits. These things sound absolutely great, and I built 2 of them so that I could be able to record in stereo. Then another filter, so that I now have 2 filters in this system altogether, a 3rd gate, and then finally a simple mixer. This mixer has 2 sides, 2 channels, and each channel allows you to be able to input 3 signals, as well as 1 signal coming in at unity gain. The master section is right here, and in this case I have a banana output as well as a 1/4 inch output. Down here for the other channel I have a banana output, and I am out of 1/4 inch output, so as soon as I get another one I will put it in, and then this whole circuit will be completed. So talking about this gear is all well and good, but let's go listen to a couple of sound examples of things that I've already done on this system. So that's it for this episode of Under the Big Tree. As always, if you like what we're doing here, please feel free to like, share, and subscribe. For now, this is Nick, signing off.